Hi, everybody.
Hi.
Welcome to the NJAA. Tonight, Al Witzgall is going to talk about we'll give you a Mars exploration update. Al is the vice president of this club. He's had a lifelong interest in astronomy, and he's a professional optician. So, lots of talents. Here we go, Al. All right.
Good evening, everybody.
Good evening.
Thank you for coming, especially at a time when the temperature is so murderous this morning. And the funny thing is, if you're a planetary observer, you're looking for this kind of very warm, very hazy night, because it means that the atmosphere is strangling to us, but it stabilizes the air and it makes it easier to be able to see detail on our subject over here, Mars. How many people have looked through a telescope and seen Mars? Okay, a couple. Okay, good. Terrific. How many saw a lot of detail on it? Okay, not that much. Maybe, all right, good. Okay, I'll talk to you. The idea is that it takes a trained eye to look at Mars. Now, we have made robots that are our eyes and ears, and for that matter, most of our other senses. I'm going to be talking about, as the title explains, an update as to what has been found so far, and then we'll look into the near and the far future. So let's see if this works. My God, it does. We're actually past opposition. That was on the 22nd. On the 30th, however, will be a closest approach, just about 60 million miles away. A pretty good apparition, as it's called. But since it's near opposition, the best time other year to view the planet, we're going to have an overview of what NASA and the European Space Agency are doing currently and upcoming spacecraft. So this is your basic Mars. One side, then 180 about to the opposite side. What you're looking at over here, of course, is, since everything is inverted in a telescope, north is down here. These are the polar caps. The southern polar cap has a hood on it, which means this haze, which means that when these pictures were taken, in the southern hemisphere, it was a nice summery day, about 0 degrees Fahrenheit during the day. Here, at night, it drops to about almost 200 below. Very thin atmosphere. But look at the beautiful detail here. People, especially in the first couple rows, can see some of these small craters all through here. Since Mars is about 149 million miles away from the Sun, it's close to the asteroid belt between Mars and Jupiter, so therefore it had a lot of hits over its history. On the opposite side over here, you're looking at Valles Marineris, the one and only supposed canal of Mars that's real. It's a volcanic fault, huge canyon. 4,000 miles long. It can be seen from Earth under really good conditions. These photographs are taken by the Hubble Space Telescope back in 2003. Its closest approach for the next 2,600 years. So you and I have all been alive at the time when this picture was taken, set of pictures. This is going to be in the history books and all the astronomy books for the next maybe 100 years or so. Basic physics. It orbits the Sun every 686 Earth days. Orbital velocity about 24.13 kilometers a second, a little bit slower than we do. Period of rotation, 24 hours, 24 minutes, 22.6 seconds. So the day's pretty close to ours, a little longer. It's about half our diameter, about 4,200 miles in diameter. Surface gravity, if you weigh 100 pounds here, you're about 37 up there. It's much lower. And escape velocity, here you got to go about 11.5 kilometers per second. There it's about 5. That comes in handy when you're looking for free samples from the red planet when meteorites are kicked off the surface. We'll talk about that later. Similarity to Earth. Water is frozen under the ice caps. Most of the ice that you see in a large telescope is actually, when it's winter, is actually carbon dioxide, dry ice, frozen in those incredible temperatures. Again, the day's about a half an hour longer than ours. Earth's tilt is about roughly 23.4 degrees, Mars 25. So basically, we're kind of cousins, if you will, as instruments go. And interestingly enough, this is a Viking Lander 2 photograph, and that white material over there, that is not sand, that's frost. And about a half an hour after the picture was taken, that all evaporated. This happens all the time on the red planet. Again, gravity is less, 2.7 times less than here. There may be health problems. I don't think so, personally. Mean surface temperature is only about minus 65 degrees centigrade. It's pretty cold. It only gets about half the energy of the sun because it's that much further away from the sun compared to Earth. And the atmosphere is mostly carbon dioxide, and there's hardly any free oxygen there. And what's worse is, too, it has almost no magnetic field at all. We have a very powerful one here, which is basically protected life on Earth from radiation from the sun and from stars. But there's nothing really there on Mars to protect it very much. The levels we figure on orbit around Mars, about 2.5 times that you would have here on Earth. Again, the magnetic field keeps out all that solar and cosmic radiation, or most of it. And on Mars, it'd be a little bit lower and vary with altitude. Local magnetic fields, you're in the deep valley I just mentioned. Valles Marineris, about 5 miles below the mean surface. You're probably a little safe, maybe. Go climb its highest volcano, Olympus Mons, and you're probably getting a chest x-ray every 20 minutes. And solar flares, of course, are that wonderful star out there that at the moment is kind of calming down in solar activity, increases the radiation. And this is a quick comparison. I'm going to race through this real quick. If you notice, Mars has about 95% carbon dioxide compared to, on Earth, about not even a tenth of percent of carbon dioxide here. Nitrogen, we have far more nitrogen and much more oxygen. Lucky us. Okay. This is the lay of the land. North is up, and the color coding over here indicates altitude. So you can see there's that valley I mentioned before, more like a drainage valley coming to this large northern ocean. That's what it appears to be. There are the large volcanoes I had mentioned. And these two big hits, we'll talk about Hellas and Argyre later in the talk. Two large objects crashed into them. Hellas Basin over on the right there, by the way, is about the size of Texas. That's a big crater. Okay, to get to the red planet, this is how Curiosity did it and how another spacecraft in 2020 will get there. Basically, it came in on a science fiction device, a jetpack, and came down within, I think it was within about 30 feet, about 10 meters off the surface, lowered the spacecraft, the actual rover, down to the ground on cables. Explosive bolts fired. Those cables were cut, luckily all 4 of them. I had personal nightmares that what would happen was that I would think that all 4 were cut, and the sky crane would then fly away, carrying it with it. It did not happen, thank heavens. NASA makes them good. Okay, this is, of course, the Mars laboratory, known as Curiosity. Lots of equipment all aboard. I'm not going to go through all these wonderful abbreviations. They got somebody in an office at NASA that comes up with these great abbreviations for everything. The sieves and scoop at the bottom. Collection and handling for in situ Martian rock analysis, CHIMRA. Where they get this from, you know? Mars hand lens imager. I'm trained as something of a geologist, so I like the Mars hand lens imager, or MALI. There's a number of abbreviations through here which I think are really terrific, but those are my favorite ones. And of course, the Mars descent imager. As this was coming down, it was actually taking films of the event as it was coming to a landing. Mars Descent Imager, or MARDI. So this is quite a vehicle. It's about the size of a small SUV. It's the largest rover that has ever been landed on another planet, and particularly on Mars. And it's not too far to walk. It landed perfectly in Gale Crater, and that's Mount Sharp in the distance. And by the way, after a period of 2 years, it actually made it to the foothill, if you will, of that large mountain. And it's right now climbing slowly but surely up Mount Sharp. The reasoning, to be able to explore different types of rocks that were brought from deep within the planet, pushed up after the formation of this crater, an impact, hit it, knocked a hole in it, and the stuff rebounded, forming that mountain. It's already doing a lot of analysis work. And these are not official names. They're just named by the team that did the imaging, which is fun. This is Rock Nest. We think what we're seeing over here, not only are these wonderful basaltic rocks off to the left and down toward the lower right, but more importantly, this is where we believe water flowed, carrying them with it. And you can even still see some of the remnants of the marks from it. Now, I've got a question for people here. Both of these pictures were taken by NASA. Okay? Which one of these is Earth and which one's Mars? How many people here think that the Mars one is on the right? Put up your hands. Okay. That's Earth. And that's Mars over here. And the kicker is flowing water rounded all these little rocks on both worlds. So at one time, there was quite a bit of water. We figured that there's enough that if there was a way that you could defrost all the ice that's underneath the surface, the oceans are still there, they're frozen underneath a couple meters of dirt and dust. If you were able to defrost them magically, it would form oceans about a half-mile deep. So it's a potential for that again in future someday. Earth, of course, has tons of water. Not much to drink, unfortunately, but yes, we have a lot of water here. And where there's water, you sometimes get deposits of sand, and they're buried by others, and on and on and on, different layers over many, many thousands of years. Then it gets compressed by its own sheer weight into rocks like sandstone. And the kicker is that if you have sandstone here on Earth, sometimes remnants of life, seashells, bones, even plants and such, will be preserved as fossils. So of course, every time I look at this picture, I say, yeah, a good field geologist could get out there with a hammer and a chisel, and maybe they'll find a nice Martian scallop. That would be incredible. Even though the thing could be dead a 500 million years, it doesn't matter. It showed life at one time did exist there. And this is from the OOPS file. This is a very recent picture. Curiosity has a rock drill which is able to go about an inch or two, no more than that, into a given rock to take samples in the form of powder and then import that into the vehicle and then analyze it there. So almost like a field geologist having a geophysical laboratory with them. But sometimes it's a dangerous thing. What's happened over here is that the drill didn't just go through it to get a sample, it also broke the rock. And in doing so, it could have jammed that drill. Now, there are provisions that if something like that happens, they could disconnect the drill and put another one on. I think they have like 3 more replacements. Luckily, that didn't happen, but they did get a sample. But this is a little scary when you really think about it. It could have been a disaster. Imagine having your rover. It's all set to go. It's nuclear powered. It's got maybe as much as 4 years of fuel, nuclear fuel left. And suddenly you get stuck on a rock, and now you got to kind of pivot around to do any kind of research. That doesn't work too well. Okay. And then there are these pictures where there appears to be anomalies, things that should not be there, but apparently they are. And somebody looked at the upper part of that, and they thought they saw a skull, which has been wonderfully enhanced by somebody in the National Enquirer, I believe. And at the bottom, it looks like there's a vertebra of something. No, that's a normal gypsum deposit, and up there, like I said, somebody played with the picture. But, you know, you wish. It would be nice, you know. Okay. Now, I notice I mentioned that Mars had very little liquid water, and it does. Most of it's very briny, and occasionally we see evidence for it. But Earth has a very thick atmosphere, lots of water. So the idea is what happened to the atmosphere of Mars? And we have some ideas of what might have happened. In this case, maybe there was a very powerful magnetic field. There's tantalizing evidence of that on the surface. But something shut down that magnetic field. And we don't know why it happened, at least not yet. So enter MAVEN, the Mars Atmosphere and Volatile Evolution mission, which orbits the planet. It went into orbit on the 22nd of September of 2014. It is still on orbit, looking at evidence of how the atmosphere has changed, and again, what happened to the water on the red planet. Okay, spacecraft details. It's big. If you ever see a full-size a school bus, that's about the size of those solar panels. Gathers in lots of energy so it can look down. Its attitude is controlled from through X, Y, and Z axes. It has a propulsion system that keeps it on orbit and also looking down properly at the red planet. And when it was launched with fuel and such a weight about 2,550 kilograms, over 5,000 pounds. And it has, when you have even at a distance away from the sun, what's called aphelion, it has over 1,100 watts of power to work with. Okay. Now, right now, I should be telling you about the current InSight spacecraft that is heading out to Mars to become a geophysics observer. Unfortunately, there was a problem with one of the instruments. I'll talk about that in a couple minutes. So they've reset for a 2018 launch. It is going to be able to drill inside Mars and be able to look for Mars quakes and find out other details within the planet itself. Again, the idea is in the early Mars, we still had a powerful magnetic field. We had warmer conditions, much warmer, and there was liquid water. Now it's dried up, frozen. We're not quite sure what happened. So we go to a science called comparative planetology. There are 4 rocky worlds in the solar system right now. Of course, Mercury, Venus, Earth, and Mars. And we stick in the moon there just because it just happens to be part of our system. Basically, all of them have cores. All of them have mantles and very thin layers on the outside called crusts. So we compare everything to what we know here on Earth. We know Earth better than any other world. Eventually, we hope to understand what happened to other worlds. Why did Earth survive? Why did life form here? Why hasn't the oceans disappeared? Many other questions that we have no answers for. Why did Venus, which is about the same size as Earth, suddenly lose its water because somehow the planet superheated? They worry about a greenhouse effect here on Earth. Without our greenhouse effect right now, this planet would be an ice ball. We have glaciers covering the entire planet. It happened twice in our geological history. Carbon dioxide is not a pollutant. If I right now snap my fingers and all the CO2 in the world just disappeared, within a week, you'd see every plant out here die because they need it to survive. And we need plants for us to survive as well. But on Venus, things got out of hand. Its greenhouse effect kept on going and going till it hit a critical point, about 260 degrees Fahrenheit. Not even very primitive but effective life forms here on Earth in our geysers and volcanic fields could not survive that temperature. And that happened apparently on Venus, and it's superheated. Now it's a wonderful vacation place. It's 800 degrees Fahrenheit on the surface. There are open lava fields all over the place on it. We think the entire surface melted about 500 million years ago. So there are almost no craters that are seen through the very dense sulfuric acid clouds that surround it. Mercury may be a leftover from the inner solar system's creation because it's got this wonderful gigantic core. It's 3,100 miles across, and the core is almost 2,000. That's incredible. It's called the iron planet because the core is almost pure iron, just like ours is. But in its case, there's almost no magnetic field too, and the same thing with poor Mars. Okay, so InSight mission overview. A near copy of the successful Phoenix polar lander is going to be going there. It'll be launched, put it on your calendar, folks, May 5th, 2018. It will land, fast tracking, 6 months later, in November 26, 2018. What a way to have a Thanksgiving. A little late. They expect it to last at least 1 Martian year on the surface. And this is the bottom there is the surface configuration with these huge solar panels. We had that here right now, the full-scale object. It would stretch from this wall to about halfway through this room. It's a big spacecraft, mostly because of the solar panels. Okay, so its payload. It's interesting that this one came up first in the description of instruments because this is what grounded it. The seismic experiment. There is a large section. I'm going to move out of camera for just a moment again. The sensor head over here has a vacuum chamber in it, which is used to be able to detect from one station areas where seismic activity, Mars quakes, are occurring. And it has a wind and thermal shield that covers this whole thing. But because that vacuum chamber couldn't hold vacuum properly, they had to delay it. It's a shame, too, because I was hoping to get information for a talk I wanted to do in 2018. I got to wait till 2020. There it goes. But unfortunately, that's what grounded it. This is what I personally, as a geologist, would love to see information from right now. A heat flow and physical properties probe. Basically, a self-hammering nail that will drag sensors on a magnetic tape almost 3 meters underground, looking for heat coming from the center of the planet. There's a big question. Is Mars' core hot? It sounds like the Goldilocks thing. Mars core cold or Mars core warm? Each one will tell us if it's cold, it died a heat death. Basically, the radioactive elements that keep the core molten just ran out of power. They decayed and there was no energy. If it's hot, why doesn't it have a magnetic field? Something disrupted it. We don't know why or when. We have theories on it. And if it's in between, then we've got a real mystery. RISE, the Rotation Interior Structure Experiment, is basically a transponder. We'll be listening to radio signals as they go through a Doppler shift, as it moves toward the Earth, as it rotates around the core of Mars and back. And any changes in that will tell us what's happening inside. Again, is it a liquid core? Is it solid, or something in between? And of course, if you go up there, you have to have an auxiliary payload, a sensor suite, basically a magnetometer. You don't fly without having something to check out for magnetic fields. There's also a temperature, and most importantly, a system by which you can subtract the wind from the seismograph. Even with that shield on it, it may still get some problems. And then you got to put them on the ground, so you need an instrument deployment system, otherwise known as an ARM. Because basically it's going to take this self-hammering nail to go down, 5 meters, even better, dragging the heat flow sensors with it. And some people have asked me before when I've shown this, okay, Al, what happens if the self-hammering nail goes down and hits a rock? Is it going to stop there? No, it'll jitter a little bit over to one side and go back down. That's how it's designed. Clever, these engineers. Okay, this is in testing. I get an idea about how big this is. And it's a good sized piece of equipment, and I'm hoping that it gets up there when it's supposed to in the second round. Okay, now we look a little bit to the future. This is a sample return. I like to say 2020. I push it a little further, maybe to 2025. Ouch. Basically, you have a vehicle that comes out, drops a probe that lands, and picks up samples from another vehicle we're going to talk about from 2020, Mars 2020, makes sense. It will pick them up, put in a small rocket, and fire it up to the mothership, if you will, and then bring it back to Earth. There are a lot of problems that have to be solved in this, and one of the big ones everybody was probably thinking of, well, Al, what if there is still some life on Mars somewhere, microbiotic, little organisms floating around? Are we going to have the reverse of the War of the Worlds? You know, remember, if you remember that great novel and that terrific 53 movie, forget about the one in 2004. God, that was awful. The only good thing about that is that we still won against the Martians. But the 53 movie, they were conquering everything, and then suddenly, because they were breathing our air, all that wonderful little bacteria and such that we don't get affected by, wipe them out. So Earth 1, Mars 0. We could conceivably maybe have something that, if it's not controlled when it's brought in, might do something damage here, but I would debate that because we have Mars meteorites, rocks that actually got blasted off the red planet and eventually moved through the solar system, and Earth picked them up. There are about 99 separate falls, as they're called. The largest one hit a dog in Egypt in I think it was 1918. I have to look again, but legend says that it did. We never interviewed the dog, so we never found out. However, that would be the first attack of Mars on an Earth creature, if that's true. However, Nakhla, Egypt, was one of the first ones. Many others have been found since, like I said, about 99. And I'm going to let the cat out of the bag quite literally over here. Those who are interested, I have 2 of the 99 Mars meteorites here. Small chips. I'm not a millionaire. I can't afford the kilogram stuff I'd love to have. But you'll be able to see one of the more recent ones, which is very exciting. We'll talk about that later. But the whole idea is that these landed on Earth and people didn't drop like flies around it. So chances are either there's no life on Mars, or it is so alien to us that they just basically died when they got here, if they were there. But we want to make sure that stays that way. So when this goes back to Earth, it is not going to land directly. It'll probably be rendezvoused by the proposed Orion spacecraft, which I hope will be in operation by then, which will pick it up in a free-flying laboratory, and from there see if it's safe or not. And if it is not safe, literally kick it into solar orbit and get rid of it. It also then means, of course, that Mars is off limits to humans, but at least robots could go there. Okay, and yes, this is a nighttime, or I should say a early morning shot of the Earth-Moon system seen from Mars back in January 2014. The bright one, of course, the blue one is us, and the moon below it. And it doesn't show too well in this picture. I got to play with this picture because it's almost dead center in the middle of the shot. Just this little tiny little dot. That's us, by the way. That's home. You're standing on that or sitting on that rock right now. That upper light. There's a beautiful picture was taken by Voyager Voyager 1 that looked homeward from 9 billion miles. And all you see is this half a pixel. That's all it is in blue light. It's us. As Carl Sagan had said, everyone you ever heard of, everyone you're ever going to meet, at least in our lifetimes, everyone you've heard, every conqueror and savior, every king and pawn, everything, all on this little itty-bitty dot seen as a starship would look from 9 billion miles away. Almost lost in a sunbeam because it was scattering the camera. So here you got about 50 pixels. So wave next time. Okay, right now we're in the middle of a European Space Agency and NASA ExoMars program from 2016 to 2018. Right now, this guy over here, the orbiter, which is called the Trace Gas Orbiter, is going to be looking for gaseous evidence, swamp gas essentially, methane and other organic gases in the atmosphere of the red planet. And it will drop also a lander just to prove that you can have entry, descent, and landing of one of their rovers. It's called Schiaparelli, for the gentleman who first observed Mars and saw on the red planet what looked like, in Italian he described it as canali. Well, the American press grabbed that in 1877 and said, canals, there's got to be life there. I'm not kidding, this is what happened. And the rest is history, as they say. But they're actually going to go there. Mr. Schiaparelli, by the way, was a damn good observer. But his poor spacecraft, his lander named for him, will last, if we're lucky, 4 Mars days. Because they don't have nuclear power here. The Russians reneged on that. They needed it for something else. I don't know what. But they put regular batteries in it. But at least it shows that they can land in this configuration. The other animal over here, which is the 2018 Sample Gatherer and the European Space Agency's ExoMars rover. This is really a cool vehicle because, like I said, I got ahead of myself over there. The Trace Gas Orbiter. See, you can get methane and other organic gases from things that are not organic. Volcanoes produce it all the time. But you could also have life that eats rock, olivine. It happens here on Earth. If there's enough temperature and enough water, you have life that will actually metabolize rock and release as a byproduct methane. So maybe, hopefully, we might be able to get a handle as to where it's coming from and maybe be able to send a rover there sometime. Okay, the next rover from NASA is the 2020 rover. Has a number of newer instruments, different instruments, better technology. And we are, again, this is not just the United States, it's also other countries as well working with us. But one thing a little controversial is this. Maybe a greenhouse will be sent to the red planet, which will have Earth seeds completely sealed so we don't end up having a reverse War of the Worlds thing, where we will see if Earth plants could grow in the dimmer light, somewhat cooler conditions, and a little bit of water right from the Martian atmosphere on the red planet. Because if you can grow plants there, that means you can have a semi-self-sustaining colony eventually. We'll see. There we go. Now back on this. ExoMars rover can go up to 2 meters underground. But in its case, instead of putting down a heat probe, it's going to pull the samples up from that deep and analyze it to see if there's any water, ice, or a rock, and see if there's any life or signs of previous life. And this is actually... Actually, I got the idea of this from another talk, which I have yet to show up here. Someday I will. It's called OSIRIS-REx, which will be launched in 2018. In 2019, by 2019, it should come to an asteroid called Bennu, and it has a instrument, among others, called TAGSAM, which is a touch-and-go sampling device, which basically have 3 chances of coming down on the surface of the asteroid Bennu, which, by the way, is about twice the size of MetLife Stadium, just to give you an idea on scale, will come down and just bounce away and pull hopefully as much as maybe 4 pounds of pristine asteroidal material, pack it up, and by 2022, 2023, it'll make it back to Earth where we can analyze the sample and see exactly what an Earth-crossing asteroid that in the late 22nd century could potentially hit Earth. The more time we have to understand it, the better we can do something about it. But on a more proposition concept, we have OSIRIS-REx 2, because the gravity is so light on the moons of Mars, Phobos and Deimos, it can do the same trick. Come down, take a sample, put it away, then fly out to Deimos, the further moon, take a sample from another sampler on the other side of the spacecraft, block it up, and come back to Earth. And there's a theory that one of the big collisions that occurred there, I mentioned Hellas Basin before, might be the origin point of Phobos, because the composition in the surface seems to be very, very close. The only way to find out, of course, is to get samples here. And this is one way of doing it. Meanwhile, back on Earth, new technology. This is an amateur photograph. A good friend of mine, Cliff Ashcraft, has been really doing a lot of pioneering work with relatively simple webcams. And this is taken with a webcam back in, I think it was in 2015, if I remember correctly, 2014. And this is Mars as you could see it in a really large telescope from Earth. All the detail that's here is in his photograph. This is real. This is not a composition or a drawing. Not bad in the hands of amateurs. And people are doing this all over the Earth right now. Okay, now of course everybody's real big on this, so am I. I mean, the idea is how many people would like to go to Mars? I put my hand up so fast I had to have a heat shield on. And I'll tell you, I've been looking at this since the 1950s. This is the most recent concept of it. It uses a system called VASIMR, which uses heat generated by microwaves to heat up gases to an extremely high temperature, which blows it out the back. The next slide, I believe it is, will show you one proposal which takes 500 days to get to Mars. You're there for 100, then another 500. This will get you to Mars. This rocket system will get you to Mars on an opposition at a position that Mars is right now in about 39 days. And you stay 500 days on the surface, and you come home about 39, 40 days when the next crew comes out. That is the way to do it. VASIMR, you just Google VASIMIR, and you will find out all about this plasma rocket. Fantastic design. And of course, these are inflatables, which right now they're being tested, going to be tested, I should say. They had a problem with this one inflatable housing from the Bigelow Corporation that is attached to the current space station. It's only about 10 feet long. They're going to be testing, no one's going to go in there maybe more than 2 or 3 times, but they'll have sensors to see if an inflatable system can handle the radiation, micrometeoroids, little things that could put little pinholes and stuff, whether or not it would work. If it does, this is one concept that essentially would take as many, maybe as 5 or 6 humans to the surface of the red planet. And this is what's called the NASA reference mission. It's wonderful. I love having a crew come up there. It's going to spend 500 days to go out there. What happens to people in 0G in 500 days? What happens to the bones? We already know. The bone mass starts to shrink. There may be cardiac problems. So in effect, you'll get to Mars, but if you land on the surface, even the very low gravity, you may have a problem, a very bad one, and the nearest hospital is about 120 million miles away. So this is a great idea. It's got a lot of flaws in it, but at least it was an idea. Okay. What we may end up doing, though, is a remote system where astronauts do not land, but they drop down rovers. We set in free orbit information collectors, sample collectors that come up, as you can see on the far left over there, or probably far right over there, come up, which are not opened. They are sealed and stored for return to Earth. You know, it's the next best thing to being there. Instead of having a rover that essentially is photographing where it's going and it's starting to head to the edge of a cliff and basically radios back to Earth, what do I do? It takes roughly 20 minutes for the signal to say, what do I do? About 5 minutes you say, stop. 20 minutes later, of course, 20 minutes total, 45 minutes has gone by, and this is at the bottom of Valles Marineris turning over and over. You don't want that. It'd be nice if you could have 1/10 of a second or less of a radio delay from humans, which will make the decision not to do this. You could even do a virtual reality where you would put on again the crazy glasses and a glove that lets you feel as if you're really on the surface, where you're picking up a rock from the surface of Mars, even getting the texture, and then putting it into a container, which will be lifted off so you can sample it and actually maybe even look at it. Who knows? And of course, human surface explorations. I'm saying the 2030s. Ouch. That's a long time, you know, for anything. But some of the young people in here could be on that mission. You never can tell. And who knows? Maybe the first human bootprint might be around 2034, 2035. And hopefully she'll have something interesting to say back, equivalent to one small step for a man, one giant leap for mankind. In this case, maybe something like we come to the planet of war, seeking and bringing only peace and knowledge. I hope. We'll see. So I'll leave you with this from T.S. Eliot, which is, "We shall not cease from exploration. At the end of all our exploring will be to arrive where we started and know the place for the first time." And I certainly hope that some of our young people will, if they don't fly there, at least will help to set the groundwork. Because who knows? Maybe we'll have a colony out there. There was a part of the Star Trek mythos that talks about great legal instrument, the Magna Carta, or the U.S. Constitution, the precepts of Alpha 1, and the fundamental declarations of the Martian colonies. Who knows? Maybe a great-grandchild of one of our children in here just might help write it. So as I always do, I thank my wife Bonnie for helping with production. She's the one that makes sure that everything is centered and not upside down or whatever, because sometimes I can't get this to work. Bruce Bannard, who's the Insight Principal Investigator. John Andrews, who I'm surprised he's not here tonight, but that's the way it is. Program Chairman up here who asked me to give this lecture. Cliff Ashcraft, my buddy that let me borrow that photograph. The National Air and Space Administration, which has been doing a lot of pioneering work in only 50 years, less than a human lifetime. We've gone so far from launching a rocket that just about makes it to the moon, and now we're looking at vehicles that are right now going out at this moment out to the stars. And of course, European Space Agency, who is turning into a very wonderful bunch of people from various countries in Europe and in other places too. Because of time, I couldn't talk about the Indian Space Agency that first try, this is cool, first try, got to Mars on orbit and is doing incredible work with their spacecraft. Russia has had a problem. Every time they launch something out there, unfortunately, Mars 3 landed in the mid-1960s. A few seconds of signal, and that was it. Shame that. They sent a flotilla in 1969. One of them missed the planet completely. One did not get out of orbit. And the other two, one flew by through the atmosphere. We think it may have burned up. And of course, it was Mars 3. But they're helping out with other things, too. They have pretty big rocket boosters, and they're letting the United States and ESA and other places get to the red planet and elsewhere. This is an international thing, folks. We are all explorers. We are a race of explorers. Otherwise, we'd still be stuck in Africa someplace. We got out of there. We went spread around the world, various cultures, various peoples. But now we're collectively looking elsewhere, and I think it's very healthy. Because if you're a race of explorers, what better way to blow off all this young steam we have than to go out together to explore the universe? At this point, I'd say yes. I see myself in the dark robes with the black glove, and we will conquer the galaxy. Maybe we will, because if there's no other life elsewhere and we're it, then the galaxy's ours. And if not, we have to learn with other people too. So we'll see. I'm not going to go into any more philosophy over here. I'm an explorer. I want to get back into my suit, get back in my shuttle, go back up to Endeavour and get out there. So I thank you all for your attention. Thank you for coming, and good evening. Now, before I unleash these Mars meteorites, they're very tiny. Okay, so I have a magnifier, so they look big. I'll take questions from the audience if anybody's interested, unless I've stunned everybody. No questions. Thank you, sir.
Do you think SpaceX will get there first?
SpaceX itself will probably just get us to low Earth orbit, but I think that they're trying to work on a much more powerful vehicle, the Falcon Heavy, which should be able to get to Mars with a capsule. And I hope they put something in it more than just Elon Musk was here. NASA, I think, and other people believe that if this vehicle works, it's a good way to be able to cheaply get to the red planet. Red Dragon is the name of the capsule. It's heavily modified from the one they're working today. Maybe someone's got to do it, So might as well be private enterprise and engineering. Yes.
I have a really simple question. I don't know too much. Just started. Is the International Space Station like in between us and the moon, or is it like further out?
Oh no, it's
way.
I wish it was. I wish it was out there. No, it's only about 230 miles up.
Oh, so it's not
So
that far.
no,
Okay.
it's not.
It's
There's
not like anywhere like we can launch anything from there to Mars.
unfortunately
It's not
no,
even worth- okay.
but you're on the right track. Dr. Jerry Pournelle, a retired rocket engineer and good science fiction writer too, by the way, had a statement that when you're in Earth orbit, you are halfway to anywhere because you're away from this big gravity rock that's pulling everything down. When you're in Earth orbit, all you have to do is time it so that when you fire the engines on your vehicle, you go out and you can go out to Mars or to the moon or anything else. I wish we had something.
So are the International Space Station is just like it's just outside of our
Just outside the atmosphere.
Okay.
But the beauty of it is that we can do long-term observation of humans in a low-gravity field. We can see biomedical work with it too. We also can create materials that don't exist because we have gravity here on Earth. It's kind of hard to take aluminum and lead and mix them together in a gravity field and hope when they cool, they stay together. In zero-G, they do, just because there's nothing pulling them apart. And that's just it's a very simple example. But you can create materials. We might be able to do pharmaceuticals, grow crystals that on Earth only about this big in the test tube, and out there they can come up like this because there's no gravity to affect them. We'll see.
I don't understand the concept of magnetic field, and does it have any relationship with gravity?
Not really with gravity. Magnetic fields depend on the internal structure of a rocky planet, or even Jupiter, where it's big enough with enough pressure to crush hydrogen, in its case, down to a form called metallic hydrogen, where it actually conducts electricity. And around that, in Jupiter, you have a liquid metallic hydrogen, and the thing's spinning it once on its axis. This thing's 11 times the size of the Earth, spins once. Its day is about 11 hours. But because of that, 10 hours, excuse me. But because of that, it has a massive magnetic field around it. Now, Earth has an iron core, which is solid, with a liquid core around it. And because we turn once every 24 hours, we have a pretty good magnetic field. And that's been that way, we think, almost since the creation of the planet 4.5 billion years ago. That magnetic field grabs charged particles that come out of the sun, the solar wind. It either deflects them or sometimes will capture it. When it captures it, the energy transfer to the upper atmosphere gives us northern and southern lights. But because we see that, we realize that it is keeping the planet safe. Because the energy that would normally come in and knock parts, tiny little atoms in the atmosphere out and away, never to come back, now that energy has been turned into visible light. And Mars should have had a good magnetic field. Maybe it did once. We don't know. That's what we're going there. But that's why a magnetic field is so critical to a planet that would have life and water. Because once the atmosphere starts evaporating because of this big massive star out here, all its heat and light and particle energy, once that happens, then the planet dies. And if that happened to us, we could be in a lot of trouble. I thought I saw a hand. Okay, I'll get this one first.
In one of your earlier slides, you showed that the core of the planet Mercury was rather large compared to the size.
That's right.
How do we know something like that?
Because we had Messenger on orbit around it, and by watching the orbit of the spacecraft around, which I wish it was still orbiting actually, they ran out of fuel, so instead of leaving it on orbit, they deliberately crashed it to the surface of Mercury so that it wouldn't interfere with other spacecraft coming out there. But in its case, there's a theory that in the early solar system, we had as many as 20 Mars-sized objects flying around here. Some of them coalesced together, forming the Earth and Venus. And then one of them gave a glancing blow to Venus and ripped off most of its core, its original crust and mantle. And that iron core, what was left of its mantle, swung into orbit around the sun, what we call Mercury today. That's one theory. We're not sure if it's correct. What we need to do is have a Mercury lander and start looking into the core and find out if it really is that big. Can't go here.
What are some of the prevailing theories of how Mars lost its magnetic field?
Well, one of the big ones is, as I had mentioned earlier, maybe the radioactive elements that keep it hot in the core just simply died out. It's half the size of the Earth, so it didn't have as much material. The big one that really strikes me, and struck the planet too, is those two large depressions there. Those are two massive craters, Argyre and especially Hellas Basin. So it may have had a pretty good magnetic field about 3.5–4 billion years ago. But then these two things, asteroids in the case of, I think it was in the case of Hellas Basin, about 3 times the size of Manhattan, crashed into the red planet. And the shock wave disrupted all that wonderful magnetic field flow, all that iron moving along and nice and steady and stately. And it never seems to have never had a chance to be able to reform the magnetic field. At least that's the current theory. I like that one better than just the thing just died out. You know, it doesn't make too much sense to me. There were hands back here. Okay. Okay. All the way in the back then. First.
So you said that when the magnetic field of a planet dies, the solar winds and radiation basically rips off the atmosphere. Is there anything that can be done to restore, like, is there any way to restart the magnetic field, or without a magnetic field, any atmosphere that we try to create there is just going to get ripped off and we're going to be back where we started?
Right now, to our technology, I don't think there's any way we could restart it. I've heard of science fiction ideas where you literally put up a cage around the planet and generate a magnetic field that way. But I don't know how effective that would be on a planet the size of Earth. Chances are we're going to probably have our field for quite a while. Yes, sir.
How do you know for sure that a meteorite would come from Mars?
Well, first things first, we have a number of meteorites that on Earth that are quite strange compared to the normal stuff that we would have from the asteroid belt. The structures are different, the composition is different, the ages are much younger. Your average meteorite in space is about 4.5 billion years old. It's a leftover from the creation of the solar system. These things are about 1 billion, I think the oldest Mars we ever got is about not quite 4 billion years old, only one. The rest of them are about 1.2, 900 million years old, or even younger. And they also contain water. Now I mention those things because we have spacecraft that have landed. Vikings 1 and 2, Pathfinder, Sojourner, Spirit, Opportunity, and of course the current Curiosity. They have analyzed the rocks in situ, right there on the red planet. We look at the composition there and we look at these meteorites and they match it. Their error bars are so small that you can't even draw them in a chart. And it turns out that they are indeed Martian. When they look at glass that's trapped at least in one of these two, and with enough light in here you can actually see it sparkle a little bit in full sunlight. In the glass there is trapped some of the Martian atmosphere, and it matches what we have on our surface landers to a T. So that's how we know that they are indeed from Mars. Now how they got here, we have seen some craters on the sides of some of the large volcanoes that aren't round, they're elliptical, so we think something came along on a sharp angle, blasted it off, and then eventually it moved through the solar system. We got lucky. Out of 30,000 known falls, only 99 at this moment came from Mars. And we don't know how many have landed in the oceans. This planet is terrible if you're a meteoriticist. 70% cover. We lose 70% of our rocks. One shot. And that includes, unfortunately, Mars rocks. But that's how we know. And that's what makes it so doggone exciting to me, to be able to, as an amateur meteoriticist, to actually be able to literally at times to lift by hand a rock from the moon. And if you've got a lot of money and you can grind up some cheap meteorites and throw it on the ground, you can tread the soil of the asteroids. So that works out pretty good. That's Tsiolkovsky, by the way, Konstantin Tsiolkovsky, who said, to tread the soil of the asteroids, to lift by hand a rock from the moon, to orbit Mars and observe him from there, or even to land. How fantastic is that? He wrote that in 1898. He was way ahead of his time with jargon, too. Sir?
What do you think about the feasibility of mining asteroids to create space stations and spacecraft?
I think it's a great idea. They're already out there. We just got to get there.
Yeah.
And they're, yeah.
What's the feasibility of dragging one back to Earth?
Oh, we're working on it.
Yeah, okay.
There was a plan. I don't know if it's still viable. They basically wanted to send the Orion spacecraft with its human crew out about a month and a half to a near-Earth object and literally throw a bag over it and drag it back to the Earth-Moon system and then analyze it.
Why would you need people to do that?
Well, there are some things, at least with our current technology, that you still need humans to supervise. Robots can do a lot, but not that much.
Grabbing a rock?
Yeah, I know. Hey, I know it, you know it, but tell the NASA engineers that. On top of that, Orion, unfortunately, And this is my own observation, okay? This is not anything official with NJAA or any other group I'm associated with. I think that Orion is a project looking for somewhere to go.
Yeah.
The ultimate goal is Mars, but one idea was to send it on a 3-month journey to the I think it was the L4 or 5 point. There are places where the gravity of the Earth, the Sun, and objects balance. So you put something there and it stays there for a long time. And there has been theories that maybe there's dust there that was left over from the creation of the solar system. It might be a small asteroid, could be anything, could be nothing. So that was one place, a journey to nowhere. Oh boy. But as far as grabbing an asteroid and such, I think it's a very good idea, because this way, if you can grab a rock that's 20, 30, 40 feet across, maybe you can go out and grab Bennu, which is, like I said, it's about 1,400 feet in diameter. That thing will hurt when it hits Earth. Now, if you could grab it and nudge it into an orbit that will either have it miss the Earth and never come back, or throw it into orbit around the Earth, then you can examine it and mine it. If you anybody want free gold or silver or platinum? Here, raise your hand. Anybody? Okay, everybody does. Well, out there in the asteroid belt, there's gold and silver, even some diamonds, industrial, and other materials that will solve anybody's appetite for riches and wealth like you wouldn't believe, and it's waiting for us. Okay, we'll take 2 more questions. Go ahead.
Yeah, would that be, cost effective if we're getting gold or diamond or all the, anything, some from the asteroids or from the Mars, bring them back to Earth?
It might be cost effective only in paying the industrialists that have the technology on Earth and maybe on the surface of Mars to be able to build these things for them. Because building stuff in space, large vehicles, but you have to build small pieces first to bring it up to assemble. That's why I hated that reboot of Star Trek. A young Jimmy Kirk is on his bicycle and he sees Enterprise, or one of her sisters, being built on the ground. You don't do that with starships. You build them on orbit. Yeah, God, you try lifting that thing up, But that, I think, is the way that the economy will go. And when you really think about it, there's a good possibility in doing so. We could create different economies, different technologies that we could probably eliminate problems here on Earth. First off, it gets rid of war because everybody's too busy working to be able to do this and making a decent living. Maybe not no disease, but at least better treatment, food growth. It would a full-scale planetary concept of everybody working together for common goals like that just might let us live another century or so. Maybe even longer. Okay, so call me a dreamer, you're right. But who knows? Okay, sir.
Thank you, first of all, for an absolutely terrific presentation.
Oh, thank you. I tried.
Going to Hollywood. The movie The Martian, if you saw it.
I haven't seen it.
You haven't seen it, okay.
I haven't seen it. However, I know people that have, and they say that a lot of the science in there is very good.
It is good.
Yeah.
My
So I got to go, when it goes on DVD, I'm going for it.
Beautiful.
Okay, yeah.
There's a question from the internet.
Go.
Some years ago, it was reported that microorganisms were found in a Mars meteorite.
Yes.
Is that true?
Yes and no. Yes, they found structures that look a lot like microorganisms. However, and one more thing. I mentioned there are 99 of these on the ground. Okay? But they all have the same structures. Now, either that indicates that there was life on Mars, and it got into, like we have in hot springs here, got into some of the volcanic rocks, because these are all fireborne. They're all basalts of different compositions and such. Either that, or they're inorganic, and they just happen to form as crystals. Now, the only way to find out is to go there. And that's hopefully what we'll have in the next maybe 15, 20 years. We'll see. Good question, by the way. In the back, young lady.
Thank you. For the young people who are interested in getting involved, what do you recommend for experience in education?
That's a good question. That is, how do you get involved with education? You have to tell your teachers that we need this work, and you have to tell the administrators that they got to pay for this. Because science, science, technology, engineering, mathematics, STEM, it's a good idea. It needs to be expanded so that every young person, every boy, every girl realizes they have a background in science, that science is not scary, it is not nerdy, it is exciting. even when you die at math, like I used to do when I was a kid. Later on, as I got older, I found myself drawn more and more into it. Engineering is nothing more than applied knowledge. You look at principles of science and apply them to everyday problems, and technology is the result of that. The only way we could probably do it, like I said, is we need to not just the teachers, we need to tell the administrators in particular, and the politicians. I don't know how the politicians got a handle on grabbing all the money, but if they would just put the money to the schools and let the teachers teach, it'd be a much better educational system, at least in my opinion.
I think one thing, children should stay fit. You have to be fit to go out in space. You're not going to send people that aren't fit physically.
Yes and no, but I still remember
It's tough
there was
out
a
there.
but I still remember John Glenn being in his early 80s flying on. Yeah, well, when you're 86, you got to be a little careful. Even 0G doesn't help you much. But but then again, they had flown on the shuttle when it was flying. They flew a 68-year-old man who was a diabetic and had high blood pressure, and he went up there, did a fantastic job, and actually felt better because the 0G made him benefit. It's so, there was an idea of building a space hospital. Very careful way of getting people slowly up to Earth orbit. You dock with it, and the vehicle is spinning. So that for the first couple of months, you are in 0G after heart surgery, then 10%, 30%, 50%, and then before they send you back to Earth, they'll keep you for 2 months at 1.3 Gs, 1.3 times the gravity of Earth. This way you go back to Earth, and you'll be starting to leap like Superman. So that way, at least, it allows the heart to build up resistance. Not like today, where they put you in a hospital bed. They do some various wonderful surgery, I must say. But then, it's all exercise and such. And what's the fun in that when you could look out the window and see the Earth go by? It's also a morale thing too. Okay, if there are no other questions, I thank you very much for your attention. And good evening. And we'll show these up when